So last meeting, we answered number 1. Okay. As you know, this is your solution. There's 2 parts to it. Now let's move on to number 2. And as usual, please ready your calculator for faster solving. Okay, let's start. Number 2, the cantilever truss in the figure is hinged at D and E. Find the force in each member. So it's similar to number 1, basically just finding the forces. So we have 1, 2, 3, 4, 5, 6 members. Okay. So remember, our step number 1 is to start with the connection where there's only 2 members acting on it. Can anybody tell me what those connections are? What those joints are, where there's only 2 points or 2 or less than members acting on it? Okay, very good, Carla and Angela. So Ibarra and then Gary. Very good. Okay. Now there's actually another point where you can start on. Can anybody tell me what that is, aside from A and D? Correct, Carla and John. So Ibarra, Pamitan. It's E. Pamitan. Okay. So as you can see, you can either start D, E, or A. Now, remember from our first example, if you started a support, I need to know the reactions first. So I need to know, these are both pins, so I need to know vertical and horizontal reactions depending on your external forces. Okay? Yeah. So I need to solve for that if I'm going to start at either D or E. Now at A, it's not on a support, so I can directly start there. Okay? So since I don't want to solve for reactions, my choice is A. Okay? You can start at D and E, but again, you have to solve for reactions first. I don't want that, so instead, I'm going to start at A. Okay? And then next step is to draw the free body diagram. You have an external force downward here of 1000 Newton. And then just draw your forces along the members. So remember, usually we do intelligent guess. I have a force downward. To put this into equilibrium, I need a force upward. So therefore, this should be like this. So at tension. And we call that your force AB. Next, this is to the left. So to put that into equilibrium, I need a force to the right. So I'm going to choose this to the right. So we call this FAC. And now just use your equilibrium equations, summation of forces, vertical and horizontal. Since the known force is vertical, 1000, I'm going to start with summation of forces, vertical. Okay. So FAB is upward, therefore positive, and then I need to get its vertical component. So this or AB, I need to figure out the slope of that, right? So there. Oh, no, I'm given angle, so I don't need to know the slope. So this is 30. And so instead of slope, just use your trig functions. So FAB for vertical component, that's sine 30. And then minus 1000 since downward equals 0. Please solve for FAB. What's the answer? Correct, 2000. Correct, Jermaine and Angela. So, Garing and Borg. And it's positive, therefore correct assumption. So 2000 newtons. And then my assumption was it's in tension, positive, therefore correct. It is indeed in tension. So that's one force down. Next, we can continue on to summation of forces horizontal equals 0. So this is to the left, so negative FAB, horizontal component, so we use cosine 30. And then FAC is to the right, so plus FAC equals 0. Please solve what's FAC. Okay, very good. It's negative 1732.05. So correct Skylar and Kathleen. So pamat-mat and do for. Okay, so negative 1732.05. Incorrect assumption, therefore it should be 1732.05. And then my assumption was compression. So FAC is actually in tension. Mhm. Wait, eh? Wait. Oh, it's supposed to be positive. Bakit kaya negative? So, no. Yeah. F3. No, it's positive, guys. Correct assumption. Okay? This is going to be transposed to the right. So FAC equals positive FAB cosine 30. FAB cosine 30 is positive 1732.05. So it's supposed to be positive. And then since positive, correct assumption. So that's compression towards the point. That's two forces down. Now we're going to move on to the next point. So what point should I move on to next? Correct B, Skylar and Carla. No, only B. You can't move on to C yet. Okay? Since I didn't solve for reaction yet. So pamat lang. Correct. Yeah. So B, why? This is known, unknown, unknown. So two unknowns, I can move on to B. However, for C, this is known, unknown, unknown. And since I didn't solve for E yet, this is also unknown. So three unknowns. So I can't use C yet. Okay? So the answer is B. So now let's move on to solving at B. Okay. So draw your free body diagram once more. So FAB is tension. So we're gonna draw that the same way here. Okay. And now at this part, you're just gonna guess since there's no direct way to figure out if it's compression or tension. So I'm just gonna guess all of these are in tension. Okay. And now you need to figure out your angles. So first, what's the angle of FAB? So I drew a horizontal line here, drawing a horizontal line here. Remember your law of alternating interior angles. If this is 30, alternating interior to that is this, so this is also 30. Okay? So therefore, this is 30. Next, these are opposite angles. So if this is 30, it's equal to that. This is also 30. Okay? And that is this line. So therefore, this is also 30. Next, what else? Okay. Now, this line, this is 60, this is 30, right? Therefore, 180 minus 60 minus 30, that's 90. So therefore, bar BC is at an angle of 90 degrees with this bar. So that means it's right triangle. It's at a right angle. Okay. So obviously, this is also at a right angle. So to get this angle, it's just 90 minus 30, which is 60. So this is 60. Okay? Now you can create your equations. So let's name this first force BD, so FBD, and then this is force BC. Okay, so all of these have a vertical and horizontal component. So it doesn't matter where you start. You're gonna need two equations to solve for your unknowns. Okay, so my preference is just to start with horizontal. So FH equals 0. Let's start with FBD. It's to the left. So negative FBD, horizontal component, so you use cosine, then your angle was 30. Next, FBC is also to the left, so negative FBC, cosine, the angle is 60. And then lastly, FAB is to the right, FAB, cosine, 30. And remember, FAB is just 2,000. Then equals 0. And now we can call this your equation number 1. So do the same thing for summation of forces vertical equals 0. So FBD is upward, therefore positive. FBD, vertical component, therefore it's sine 30. Next, this is downward, so negative FBC, sine 60. This is also downward, so negative FAB, sine 30. And then equal 0. So now you have two equations, two unknowns. You can solve for FBC and FBD. BD, BD. Please solve what's FBD and then FBC. Considering FAB is 2,000. What? No. Mali. Okay, sorry. We have an external force here, so that's why. And my bad. I forgot the external forces. There's an external force here, 1,000. So I'm gonna add, okay, downward, therefore negative 1,000 to summation of forces vertical equals 0. Please resolve. Correct FBD is 2,500, Skylar and Jasmine. I already have 2 points. So let's give it to the next one. Jasmine and Kathleen. Alanis. Okay, and then solve for the next one. What is FBC? Oh, that's FB. What's FBC? Remember to state if it's positive or negative. Okay, correct. And Kathleen, Maria, and then Jan. So Kathleen, you already have 2 points. So let's give it to Maria and Jan, Reyes, and Torres. Okay, it's negative 866.03. Therefore, incorrect assumption. I assumed FBC is tension, so therefore it's 866.03 compression. Okay, so that's 2 more forces. Now, moving on. After B, what should be our next joint? Correct, C. Yes. Correct, Andre and Jade. So De La Vega, Simon. Okay, yeah, it's C. Again, why? Because for D, I need to solve for reactions first, and I didn't do that, so I can't go there yet. So let's move on to C. Okay, and now let's not forget the external force. So we have 1,000 there, and then let's draw. So AC, this is F AC, this is FCE, and then this is FBC, FBC, FCB. Well, now figure out if it's tension, compression. Let's start with AC, it's compression. Therefore, draw it that way. Next, how about BC? It's compression. So remember from our first example, whenever you get a negative, you can either copy what you did in the previous free body diagram. That means copying it as tension again. However, in your solution, you're going to include the negative sign. Or you're going to correct it. So now I know it's compression. So draw it as compression and just write the positive value. Okay? So I'm going to do the correcting method. So I know it's compression, so draw it as compression. Next, FCD. We haven't solved for that. So just make a guess. I'm going to guess it's here. Tension. And then lastly, CE, once again, I haven't made a guess yet. So I haven't solved that yet. So just make a guess. I'm going to guess that's compression. Again, these are just guesses. And now you're going to start solving. So my given is 1,000. So I can start there. Summation of forces vertical equals 0. Okay, since 1,000 is known, BC is also known. So the only unknown is CD. I can solve for CD using summation of forces vertical. Okay, let's start. So FCD, and then vertical component. So let's figure out our angle. So FBC, where is that? Here. This is your horizontal, so its angle is 60, already given here. So this is 60. And then how about this? Also given, 60. Okay, so vertical component is sine 60. Next, this is downward, therefore negative FBC sine 60, and this is downward, so minus 1,000 equals 0. Considering FBC is 866.03, by the way, use the stored value of this, okay? You should have stored that. Please solve for FCD. Yeah, it's 73 if you use the store function. So who got it? Skylar, correct. Jan, correct. Vivian, correct. So it's 2020.73. So Vivian and Jan. Taurus. Yan. So again, store this. 2020.73. So store that value, okay? My answer is positive, therefore correct assumption for CD, tension. Store that. The full decimal places. And then move on to horizontal. So that is F, this to the left, so negative FCD. Horizontal, so cosine 60. Next, FCE is just to the right, so plus FCE. Next, FBC to the left, so negative FBC. Once again, cosine 60. And lastly, FAC is just to the left, so negative FAC. Considering CD is this full value, FBC is this 866, and FAC is this 1732. Again, use the stored value of this. Please solve for FCE. Stored value. Okay, so, wala na bang hakabol? Yun, okay. Yes. correct. If you store it, you're gonna get 3175.43 if you use the stored value of everything. So 31 should be positive. 3175.43 positive. So correct, Julia. And then Angela. So I'm gonna give it to you. Angela. 42 ka pala. Joke lang. Mark. Okay, so Kaya, Biab, and Solomon. Kaya, Biab, Solomon. Kaya, Biab. Okay, so it's positive 3175.43. Therefore, correct assumption for CE, that is in compression. Okay, so now I have these two. And now I have completed getting everything. So 1, 2, 3, 4, 5, 6. And I solved everything without figuring out the reactions. So now you can just write the summary. So writing everything out to make it clear. FAB is 2000. Our unit was newtons. And then it's in tension. Next, FAC is 1732.05. And that is newton. That was in compression. Next, FBC 866.03. Again, that's newton, which was in compression. And then FBD. By the way, if you haven't noticed, I'm writing the summary in alphabetical order. So FBD is 2500. And this was in tension. Newton, tension. And then I'm gonna write it here. FCD is 2020.73, and that's in tension. And then lastly, FCE 3175.43, and that was in compression. And that is your answer to number 2. So if you want to check, you can solve at D and E per method of joints, but you have to solve for reactions first. And then your final equation should be 0 equals 0. But if you don't want to do that, that's fine. This is your complete solution already with your answers. Okay? Any questions for number 2? Please answer in the chat, yes or none. Okay, great. So that's your number 2. Next, we can move on now to number 3. Okay, number 3. So it looks a bit different. Determine the force in each bar of the truss shown in the figure caused by lifting the 120 kilonewton load at a constant velocity of 8 meters per second. So basically, we're still just looking for force in each bar, but now we have this additional external load that's moving. Okay, so I'll teach you how to deal with that. But for now, we have 1, 2, 3, 4, 5 forces to look for. Okay, let's begin. So velocity, 8 meters per second. Now, what do I care about that constant velocity? Well, the only thing that's important about that phrase is the term constant. So remember, in your equation for equilibrium, you have 2 states of equilibrium, right? One is when it's at rest, and the other if it's at constant velocity. This system is in constant velocity, so we can say this is also in equilibrium. So meaning we can still use summation of forces equals 0, moment is 0. Yun. So that's what all that means. I don't care about this value, 8 meters per second. Okay. Right. So now we can just treat this as your forces. We have a force. This whole contraption is being supported by this pin. Therefore, we can transfer that force this way. Okay. So that is your weight, 120, and this is also, remember, if you have a frictionless pulley, whatever is your force here is the same as here. So P is also equal to 120. Okay? And again, they're gonna act at this support. So let me denote that. So this is also 120 kilonewton. And then they're gonna act both here at your support, which is a pin. Okay, so this 120, 120. Yeah. So that's what all that is about. Now we're gonna solve normally. So we have this truss. So the first question is, what connections only have two unknowns? So please answer. Correct. Ivy, Angela, Carla, and Rosalane. It's A or D. So Angela and Carla, you both have 2 points. I'm gonna give it to Ivy and Rosalane. So Jocelyn, Ellie. Yan. 2. Mhm. Very good. Ito nilagay. Ayan. Ah, all right. So you're either gonna start at A or D. So if you're gonna start there, those are both supports. I'm gonna need to figure out the reactions. So let's solve for reactions. Yeah, sino nagsabing 12:30 start ng class? No, we start at 12. Kasi ang daming sinusolve. So we start as soon as possible. Okay. All right. Continuing. So again, I'm gonna need to solve for reaction. So this is a roller. So that's just RA, perpendicular to the surface. We have a pin here. So this is RDV. And then this is RDH. Again, all of my directions are guesses. Okay, now look. To solve for RA and RDV, you can use symmetry. Remember, your force is symmetrical, or your system is symmetrical if the force on the left and right hand side are the same. Okay? Splitting this down the middle, and the left side and the right side have the same amount of forces, which is only at C. So although this is diagonal, it's still just moving at C. Okay? So the vertical component of this is just also downward. Okay? If you draw this. So we have 120 here. The vertical component of that would also move here, and then there's going to be a horizontal component. So vertically, your system is at symmetry. And remember, when your system is at symmetry, if you have a summation of forces, you can either just put that at the center, like what we did earlier or before, whenever we have a truss with a lot of forces. Or what you can do is, for supports, you just take the summation of all the forces and divide it by 2. Okay, so let's do that. So once again, by symmetry, that means RA is equal to RDV. Again, this is only symmetrical vertically, okay? So RA equals RDV, which is equal to all your forces here. So 120 plus vertical component of this. So we have 3, 4, 5 slope. So therefore, this is 5. Okay, you can zoom in. It's given here 3, 4, 5. Slope is given. So let's use that. So plus 120 times 3 over hypotenuse over 2. Please solve. What's the answer to this? Okay, correct. Angela, Skyler, Kathleen, and then Patricia. Castillo Cruz, 96. Castillo Cruz, 96. Great. So now I have the reaction to RA. Now how about RDH? Right? What if I want to start at B? I need to know RDH as well. So to get RDH, you can just use summation of forces horizontal equals 0. RDH is to the left, so negative RDH. Next, the only thing that has a horizontal force is this P, and that's to the right. So plus P, which is 120, and then get the horizontal component. So that's 4 over hypotenuse, 5, then equals 0. So from this, I can solve for RDH. Please solve what's RDH. Correct. John, Kamitan, and Borbe. Kamitan, you have 2 points, right? No, okay. So now you have 2 points. Now, Carla, Germany. Okay, it's 96. Ang laki naman sa'yo, Jay. No, it's 96. 120 times 4 over 5. Okay, and all of my answers are positive, therefore all of these are correct assumptions. Now that you have your reactions, you can either start at A or D. Okay, I'm gonna start at A. If you wanna practice solving, you can start at whichever joint I did not choose. Okay, so start at D for you guys. So anyway, starting at A, free body diagram. We have reaction here. Next, just draw your forces. So we have this and then this. Okay. Once again, intelligent guess, we have upward, therefore this force should be downward, and that's your FAB. This is to the left, therefore this should be to the right. And that is your FAC. And then there's no angle given, right? You're given dimensions, so that is getting the slope. This is 8, this is 6. Writing this all in simplest term, okay, divide everything by 2, right? 8 divided by 2, that's 4. 6 divided by 2, that's 3. And now you have the special right triangle, 3, 4, and we already know hypotenuse of that would be 5. Okay, so 3, 4, 5. And now you can start solving. Summation of forces, I'm going to start with vertical since RA is what I know, equals 0. So RA is upward, therefore positive RA. Next, FAB is downward, so negative FAB. Get the vertical component. This is your AB, so vertical is 3 over hypotenuse 5. Then equals 0. Knowing that RA is 96, please solve for FAB. What's the answer? Correct, it's 160. Correct, John, Skyler, Kathleen, and Kathleen. So Relor and Castillo. So 160. Positive, therefore correct assumption, that's compression. Next, summation of forces horizontal. Okay, this to the left, therefore negative FAB, get the horizontal component, that's 4 over hypotenuse 5. Next, FAC to the right, so plus FAC equals 0. FAB is 160, therefore please solve for FAC. Correct, it's 128. So correct, John, and then Adriel. So Relor Rivera. Relor Rivera. 128. Once again, it's positive, therefore correct assumption for AC, away from the point, so that's tension. So now I have 2. Moving on, okay, where should be our next, or what are the possible points to solve on next? All right, correct, Skylar, Maria, and then Nicole, Patricia, so Reyes, Cruz, and now there's another point. But what else? So C lang ba? Correct. B, it's B. So we got that. Correct. Vincent, Patricia, and Pauline. So Cortades only. Cortades only. Okay, yeah. It's B. So checking B, right? FAB known, unknown, unknown. So only two unknowns, so possible. At C, same thing. Known, unknown, unknown. So possible. Now usually I want to start at C because there's no diagonal. So you can do that. But again, for the sake of being thorough, I'm going to do the opposite, which is start at B. Okay, so there's no fixed order of how to solve for things. Just remember to follow solving for the joint with just two unknowns. Okay? And whatever you're used to. So let's start. At B, let's draw. So FAB is compression, so I'm going to draw that towards the point. So FAB, what else? I have FBC. I'm just going to draw that. FBC, and then lastly FBD. Okay. So I'm just gonna guess, since I want this to be symmetrical, I'm just gonna guess this is also compression. And to counter that upward force, this FBC, I'm gonna guess it's tension. Okay, now that you have your free body diagram, once again, you're gonna use your solution. Okay. Or you can also do the intelligent guess. Since this is to the left, I need to counter that. So I'm gonna choose FBD. Sorry, since this is to the right, I need to counter that. So FBD would be to the left. Yeah. And as you can see, it's symmetrical. Again, what does symmetrical mean? Left equals right side. This is the left, this is the right. And they look like each other. So they are mirrors of each other. So by symmetry, okay, I can say FAB is equal to FBD. Okay? Again, symmetry. This looks like this. There's no other external force to remove the symmetry. Okay? So therefore, FBD is equal to what's AB 160. And it's also in compression. So by symmetry, I easily got another force. And now I'm left with FBC. I can solve that using summation of forces vertical equals 0. Okay? So continuing, FAB has this slope. So vertical component would be FAB times 3 over hypotenuse, 5. Okay? And then FBC is downward, so negative FBC. And then lastly, FBD is upward, so positive FBD. Once again, this is your FBD. Base is 8, height is 6, which is the same as this side. So it has the same slope, which should be the case since, again, they are symmetrical. So this should have the same slope as this. So therefore, the vertical component of that is also 3 over 5. So 3 over hypotenuse 5. And then equals 0. And now you can solve for FBC since FAB and BD is 160. Please solve. What's the answer? Not 0. Correct, Jade, Skylar, Sophia. So De Leon and De Leon. 192. Yes, it's 192. Plus. So 192, positive, therefore correct assumption. FBC is away, so that's tension. And then I'm only left with one more unknown, which is FCD, and I can solve for that using either this joint or this joint, and those two are the ones that are left. So up to you. You can either use this or this. Okay? But let's say I didn't solve for the reaction here. I'm gonna use this. Okay? So at C, okay? So drawing that. So how will I draw that? Okay. So we have FBC. FBC is tension, so away from the point. What else? We have FAC. AC is tension, so once again away from the point. What else? BD, I'm gonna guess that's away from the point. Oh, sorry. CD rather. CD. Then we have external forces. Your weight, which is 120, which, as I've said earlier, acts at your support pin. This is your pin. So draw it that way. And then on the same manner, this line, this tension force also acts there. So draw it that way. And this is again 120. And remember, this force has a slope 3, 4, 5. Okay, so that's your free body diagram. Once again, what are we missing? FCD. So therefore, I'm going to use summation of forces horizontal equals 0. Okay, FAC to the left, so negative FAC. We have 120 to the right, therefore positive 120, and then get its horizontal component. Horizontal is 4 over hypotenuse 5. And then lastly, to the right, so plus FCD equals 0. Knowing that FAC is 128, please solve what's FCD. Correct, it's 32. Correct, Julia, Kathleen, Adrian, Rivera, and Solomon. Okay, 32. Positive, therefore correct assumption, away from the point, so tension. Now I have gotten all of the unknown forces. Now again, if you want, you can continue on with solving for D and checking if 0 equals 0, or your equation will equal to 0. Okay, that just means what you did so far is correct. All of your solution for forces are correct. Okay? But I won't do that anymore. So instead, I'm just going to write the final answer. So I'll write it here. Okay, again, I want to do it alphabetically. So we'll start at AB. FAB is 160. Our unit is kilonewton. So 160 kilonewton, and then that is in compression. Next, FAC, 128 kilonewton tension. FBC, 192 kilonewton, and again, that's tension. FBD, here, 160 kilonewton, and again, that's compression, and then lastly, FCD, 32, again, kilonewton tension. That is your final answer. Okay. So any questions for number 3? Please answer in the chat. Okay, great. Since you don't have any questions, I can move on to the next problem. Number 4. Okay, number 4. Compute the force in each member of the Warren Trust shown in the figure. Okay, so now we have the name of the trust. We have Warren Trust. So what does that what does that mean? So Warren Trust is a trust composed of equilateral triangles. And remember from your geometry, equilateral triangles mean all of their interior angles are 60 degrees. So 60, 60, and therefore this is 60. Okay? Because remember, summation of interior angles of a triangle is 180. So 60, 60, that's 120. 180 minus 120 is also 60. So 6, 12, 18. Equilateral triangles. So these three are equilateral. So that is what a Warren Trust is. That's all you need to know about Warren Trust. And then the question is, compute the force in each member. So the same routine, we're just gonna continue or repeat what we've done so far. So this is just basically practicing how to solve by repetition. Okay, let's start number 4. Again, this is equilateral, so I just know this is 60, 60, 60. Another thing with equilateral triangles is that if I draw an angle bisector, which is just an angle dividing a line that is dividing your angle into two equal parts, and then perpendicular, oh no, not necessarily perpendicular, but hitting the opposite side. But since this is an equilateral right triangle, oh no, an equilateral triangle, it's gonna be perpendicular. Another thing is this line is gonna divide the opposite side into two equal parts. So this is 10. Therefore, this line divides it into 5 and 5. Okay? So that's one property of equilateral triangles. So 5, 5, same thing here. This is also 5. 5 feet, 5 feet. Okay? Yeah. Right, so after analyzing that, we're gonna choose again which connection has only two unknowns. So tell me, what are those? Correct. It's A and E, or A or E. So correct, Carla, Angela, Jasmine, and then Ivy. So Justin, Alanis. Alanis, Justin. Okay. So A or E. So again, up to you. A and E are both supports. So again, I need to find out the reaction. So let's figure out the reaction by using our equilibrium equations. Okay. So let's draw that. So this is a roller, okay, as you can see. So there's only one reaction there, your RA. This is a pin, so there's gonna be two reactions. However, there's no horizontal force, so therefore there won't be any horizontal reaction. So this is only RE. So even though this is a pin or hinge support, there's only one reaction because there's no horizontal external force. Okay, now remember from your equilibrium topic, to get the reaction, first step is to solve for moment. So summation of moment, and then you're gonna choose one of the supports. I'm gonna choose E. So summation of moment at E equals 0. So let's start with RA. Rotate it about E, that's clockwise. So positive RA, perpendicular distance is 10 plus 10, so 20. Next, 1000, rotate it about E. So that's counterclockwise, negative 1000 pounds. Perpendicular distance, this is 10, plus this distance, which is again 5, so that's 15. And then lastly, we have this 3000, rotate it about E, that's counterclockwise. So negative 3000 times this distance again is just 5. And then equals 0, I can solve for RA. Please solve, what's the answer? Bakit 0? Negative, negative lang. Correct. Julia. Angela. Wait, no, not Angela. Only Julia. Julia. Ako ba yung mali? Nagaling. 4A times 20 minus 1000 times 16 minus 3000 times 5. Oh, am I missing an external force? Yes, I am. We're missing an external force. I forgot this. Okay. So I'm missing 4,000. So let's include that. Yes, yes. Thank you, Julia. Okay, so 4,000. Rotate it about E, that's counterclockwise. So minus 4,000 times perpendicular distance 10 equals 0. Ayan. So once again, yes, code for operation. Correct, it's 3,500. Correct, Julia. You're the first one who noticed. And then Johnson. So Solomon and Balibar. Solomon, Balibar. And then Jade. Ano, 2 points ka na pala. Okay, so 3,500. Okay, so positive, therefore correct assumption, it's upward. And now to solve for RE, that's just summation of forces vertical. Or if you want, you can do summation of moment at A equals 0. RA is upward, therefore positive, minus 1000, minus 3000, minus 4000, equal, plus RE equals 0. Please solve. What's RE? Correct, Skylar, Rosaline, Shanine. Sophia. Okay, so nakato ka na ba? Nope. Okay, so Rosaline, and then Shanine. So Santa Ana. Okay. So 4-5. Okay. Now I know the reactions. It's time to actually do your method of joints. So you can either start at A or E. Up to you. Again, I want to start at A. And then free body diagram. RA. Okay. So intelligent guess, this is upward, therefore this is downward. This is your force AB. And then this is your force AC. This is to the left, so this should be to the right, FAC. And then angle is given. So this is 60. Now you do summation of forces. Again, vertical force is what I know. So I'm going to start with summation of forces vertical. RA is upward, so positive. FAB is downward, so minus FAB, and then get the vertical component, that's sine angle, which is 60. And then equal 0. From this, please solve what's FAB, knowing that RA is 3.5. Correct, Angela and Jermaine. Mga 2 points ka na ba, Jermaine? Yes. So, sunod. Adrian, correct. And then Shanine. So, Rivera, Santa. Rivera. Rivera. Naka 2 ka na, Rivera. Sino pa? Walo. Yes. Okay, correct again, Johnson. So 4041.45. Please store this value because we're gonna use it again later. So positive, therefore correct assumption, that is compression. Okay. Next, summation of forces horizontal. To the left, therefore negative FAB cosine 60. To the right, therefore positive FAC equals 0. Knowing that FAB is this, remember, use a stored value. Please solve for FAC. Correct, Skyler. Correct, Noel. And then Jade, and then Vivian. So Bajo, Salvo. Okay. So it's 2020.73. Correct assumption, therefore that's tension. Again, store that value, okay? So I have 2 out of 1, 2, 3, 4, 5, 6, 7. Rami. Okay. So next, what's our next connection? What should be our next connection? What do you think? Correct, it's B. Correct, Skyler, Bermain, Joanna. So Joanna, Tamano. And then was Jasmine. You already have 2 points. Carla also 2. Kenya. Okay. Carlo, correct. So it's B. Correct. Once again, why? Because B, known, unknown, unknown. So just 2 unknowns. While let's see, known, unknown, unknown. So we have 3 unknowns. So starting at B, once again, draw your free body diagram. Okay. There. FAB is compression. So copy that here, FAB. What else? We have this FBC, and then this is FBD. Now look, I have a force to the right, so to count, I have a force upward. So to counter that, this should be downward. And then FBD, I don't know. You can just guess. I'm gonna guess to the left. So yeah, since we have both, I don't know. You can intelligent guess pala. This is to the right, this is also to the right. So to counter everything, this is to the left. And now you can use your equilibrium equations. So you can either start at vertical or horizontal. You're both gonna get answers. Let's start with vertical. Okay, and then let's include our angles. So again, alternating interior angles. If this is 60, therefore this is also 60. So this is 60. Okay. Same thing here. Alternating interior angles. This is also 60. So 60. Okay, let's start. FAB is upward, so positive FAB. Vertical component, so use sine angle, which is 60. So this is downward, so negative FBC. Minus FBC sine 60. This doesn't have a vertical component, so 0. FAB is this value, so I can solve for FBC. Please solve. What's the answer? Is it positive? Oh, I forgot the external force again. We have a 1000 here. So that's one thing that gets me. I keep on forgetting external forces. So try not to do that as well. So we have a minus 1000 here. So please solve again. And then remember to tell me if it's positive or negative. BC. Okay, correct. It's positive. Okay, sorry. Positive pala. So correct, Adrian, Jade, Pauline, and then Carla. So phony but two. So positive 288, 6.75. The correct assumption, it was tension. Again, store that and then do the same for summation of forces horizontal equals 0. So to the right, therefore positive FAB cosine 60. To the right as well, so positive FBC cosine 60. This is to the left, so negative FBD. That's it. Equals 0. And then from this, I can solve for FBD. Please solve. What's the answer? Correct. 3464.10 or 1 pound. Okay, is that 3464? Correct. Skylar, Jermaine. No, it's positive. Adrian, Sophia. 2 points naman. Not yet. So correct, Sophia. And then correct, Noel. From Salvo. Okay. So that was 3464.10. Positive, therefore correct assumption for BD, it's compression. Okay. So I have 2 more. Next. Okay, hindi na ulit kasha. Okay, let me just make this smaller, okay? And then here. Right. Okay, so I'm done with A and then B. So I can either start at C or D. I'm gonna give it. I'm not gonna ask it anymore. So we can do C or D. So this is known, known, unknown, unknown. So 2 unknowns, I can solve at C. Same thing with D, known, unknown, unknown. So I can start with D as well. So this is just a matter of preference. I'm gonna start at C. So at C. So I'll draw that. This is your C. So we have this. Don't forget the external force. 4,000. And then FAC, FCE, and then we have two diagonals. This was BC, and then CB. FBC, FCB, and then angles are given 60, 60. 60, 60. Then figuring out is it tension compression. FBC is tension, so draw that away. FAC is tension, so draw that away. FCD, unknown, unknown. So once again, you're gonna guess directions. I'm gonna guess all intention. There. And now start with your equilibrium equations. So let's try starting with vertical equals 0. So FBC is upward, therefore positive FBC sine 60. CD, positive FCD upward, so sine 60. What else? We have 4,000 here, so minus 4,000. There's no other vertical forces, so equals 0. Please solve what's FCD. Knowing that FBC is this. Again, use the stored value. Correct, Angela, John, Johnson. Kathleen. 2 points na natin. Pamitan as well. Yeah. Who else? Carla, correct. Diba two? Okay. And then, Kayabiyab. Okay. And 1732.05, correct. 1732.05. Since positive, correct assumption, so it is indeed tension. Next, horizontal. Okay, so to the left, so both negative. So negative FAC minus FBC cosine 60. This to the right, so both positive. FCD cosine 60 plus FCE equals 0. FAC is this. Again, use the stored value, okay? BC is this. CD I just solved for. So I can solve for CE. Please solve what's CE. Okay, 2598.08. I'm gonna give it to Angela and Jade. So, Daring Simon. Daring Simon. The CD. Okay. So 2598.08. Correct assumption. Since positive, therefore it's also tension. And then lastly, I'm only missing one more force, which is this, FD. So you can solve either at E or D since I know the reaction at E. Okay, so you can do that. I'm gonna do this at D. Okay, draw your free body diagram. Okay, don't forget external force 3,000. 3,000. Yes, Erwin, it's 2598.08. And then we have this, and then That's BD. The other one was CD. And then lastly, what we want to look for is FD. Okay, figuring out if it's compression or tension. BD is compression, so draw it that way. CD is tension. And then lastly, DE, I'm gonna guess that's compression. Since we have two forces downward, to counter that, I'm gonna do this upward. Okay. And since DE is what I need to figure out, you can either use summation of forces vertical or horizontal. You can get the same answer. I'm gonna try vertical. Okay. So vertical, you have 3,000 downward, so negative 3,000. FCD is downward as well, so negative FCD. And then let's note our angle. So remember, your Warren truss is composed of equilateral triangles, right? So this is 60. This should also be 60. So that's 60. Okay. On the same manner, this is also 60. Okay. So FCD vertical, so sine 60, and then lastly FDE is positive, so positive FDE since upward, and then sine 60 as well equals 0. FCD, I just solved for that. It's this value. So use the stored value of that, and then you can solve for FDE, which is correct, Skylar, and then Mark. So pamat mat kaya yan. Okay, very good. So once again, that was 5196.15. And then, since positive, correct assumption for DE, that was compression. Okay, now I'm complete with all of your answers. You can write the summary. So therefore, again, I'm going to write it alphabetical order. FAB equals 4041.45. Don't forget the unit, pounds, and that was in compression. FAC 2020.73 pounds, and that was in tension. BC 2886.75 pound tension. BD 3464.10 pounds compression. FCD 1732.05 pound tension. And then FCE 2598.08 pounds tension. And then lastly FDE compression. 5196.15 pound compression. Okay. And as usual, if you want to check your answer, you can continue on to solving at joint E, and then summation of forces horizontal for joint D, and you should get 0 equals 0 if you want to check. Okay, so that is your final answer for number 4. Do you have any questions? Please answer in the chat. Hey, sure, wala. Okay. So since you don't have any questions, I'm gonna move on to the last item for method of joints, which is this. So determine the force in members AB. Oh wait, okay. 3 points gonna noted. Sorry. So once again, determine the force in members A, B, B, D, B, E, and D, E of the Howie roof truss shown in the figure. So now we're not looking for all of the forces. We're looking for specific ones, A, B, B, D, B, E, D, E. So, yeah. So that was A, B. I marked it out, A, B, B, D, B, E, and D, E. Okay, so I marked out the forces that we want to know. And then it was specified here, it's a Howie truss. So previously, we know that a Warren truss is equilateral triangles. Now, what about a Howie truss? Now, for a Howie truss, okay, the property is all diagonal members should be in compression and all vertical members are in tension. Okay, so by that definition, it's easy for us now to indicate if your force is compression or tension just by the definition. Okay, so we're gonna follow this. And I've already laid out the solution, since this is just again a repetition of the process of method of joints. So let me just walk you through this. So I need these forces, okay? I'm gonna focus at AB. To get force AB, I can start at joint A. And then to start at joint A, I need the reaction at A. Since there's no, since this is a roller, the only reaction there is perpendicular to that, which is vertical, okay? So my first goal is to get RA. To get RA, I'm gonna use summation of moment at H equals 0. So you have that here. So just follow the steps for summation of moment. You're gonna get RA is 4.725. Now you're gonna do method of joints. So draw the free body diagram at A. You have RA upward, then AB and AC. Again, intelligent guess. Or just remember, by definition, how we trust all diagonal members are compression. So I drew it at compression. And then to put this in equilibrium, this is to the left, this should be to the right. And then use summation of forces vertical equals 0. And we're gonna get FAB is 9.45. Positive, therefore, compression. And then I'm gonna need to get this and this next. Okay? And to do that, I need to solve at B, joint B. However, this is also unknown. I'm gonna have 3 unknowns. So does that mean I need to solve at joint C first? Well, you don't have to. Why? Okay. So we call it by inspection. Just looking at C, right? You already know the only vertical forces would be this, FBC, and then to counter that, you have your 2.7. So I already know my force FBC will be tension. Since this is downward, this should be upward. That's away from your point. And if you do summation of forces vertical, you're gonna get FBC equals 2.7. Okay, since again, these two are the only vertical forces. So just by looking at it, I know FBC is 2.7 kilonewton in tension. Okay, so that's what I wrote. By inspection, FBC is 2.7 in tension. So now this is known. This is known, unknown, unknown. I can solve for joint joint B. So draw that, joint B, drawing that, and then you can do summation of forces, horizontal and vertical. Okay, so if you do vertical, you're not gonna be able to solve for anything, right? So this is just your equation 1. And then for horizontal, this is just your equation 2. So equations to unknowns you can solve. Now, how did I get these angles? By looking at it, okay, if I draw this line, summation, alternating interior angles, therefore this should equal this. So this is also 30 in the same manner. Okay, alternating interior angles, this should equal this. So this is also 30. And then this is a right triangle. So 30, this is 90, right? So 180 minus 90 minus 30, we're left with 60. Or, since this is vertical, this horizontal, angle between them is 90. 90 minus 30, you also get 60. Okay, so that's how I got those angles. Yes. And then these are opposite angles. This is 30, therefore this is also 30. And so that's how I get 30, 30, 30. And 30, 30, 30. And you already know how to do forces vertical and horizontal, right? And then, drawing your FBD, remember, by definition, how we trust all of your diagonals are compression. So as you can see, all of them are towards the point, and then your vertical members are in tension, and that's how I drew that, in tension. Okay? Then following that, my answers are all positive because it follows the direction of your Howie truss, or it follows the property of your Howie truss. So FBD in compression, FBE in compression as well. And then lastly, I need to know this, right? So I'm gonna solve at joint D. So solving at joint D, draw your free body diagram. Okay, you have your FBD and FBF, and remember they're both diagonal members, so diagonal forces. They're in compression. So as you can see towards the point, FBE is a vertical member, so that should be in tension. So that's why away from the point. And then now, if you've noticed, this free body diagram is symmetrical. And again, for symmetry, left equals right. So therefore, FBD equals FDF in magnitude, okay? So FDF equals FBD, which is equal to 6.75, which is what we solved for earlier. That's our FBD. Okay. So FBD is known. Remember, this is our goal, FDE. So now I can just use summation of forces vertical equals 0. Okay. Summation of forces vertical, FBD sine 30, right? Since upward. And then your angle, how did I get the angle? Same concept, alternating interior angles. This is 30, so therefore this should be 30. Okay. And then in the same manner, you have your parallel angles. Okay. These two are what we call parallel angles, so they are equal, which is this and this. Okay, so therefore this is also 30. So try to remember your laws for angles for geometry or from geometry because you use that a lot in mechanics. Okay, so that's why this is 30, this is 30. And just solving normally using summation of forces vertical, you're gonna get FDE 6.75 kilonewton. And again, it's a vertical member, so it should be in tension. So that's why this is positive as well. Okay, so one benefit from knowing what type of truss you have is knowing I didn't have to guess for anything. Okay, I already know it should be in tension or compression just by definition. Okay, and that's how you solve for Howie trusses. So this method, for this question, we were looking for specific members, specific forces. Okay, we're limited to method of joints because that's the only thing I've discussed so far. Now later on, after your break, I'm going to discuss method of sections, which is an easier approach to solving for this type of problem. Okay, so that's number 5. Do you have any questions? Please answer in the chat. Okay, how about the others? Please answer as well. Okay, great. So that ends your topic for method of joints. Again, next after your break, we're gonna discuss method of sections, which is a considerably shorter solution to method of joints. Okay, so I'm gonna let you have your break now. It's gonna be 30 minutes. Okay, so come back at 2 p.m. Okay. Have your break, go rest up, so we can solve again. Once again, come back at 2 p.m. Right. So we're done with method of joints. Now we're continuing with method of sections. Let's talk about it. So remember, for method of joints, we used concurrent force systems to solve. So that's basically just summation of forces vertical and horizontal equals 0. But now, for method of sections, your analysis is for non-concurrent force systems. So I wasn't really able to discuss equilibrium of non-concurrent force systems, okay? But basically, it's just the combination of equilibrium of parallel and concurrent force systems. So concepts are the same. So that is what we'll primarily use. So non-concurrent force system, that means we're using the three equilibrium equations. Your Fx equals 0, Fy equals 0, and moment equals 0. Okay? So previously, whenever we're doing method of joints only, not looking for reactions, we're just confined to Fx and Fy equals 0. So now, put into consideration your moment. So as I've said earlier, method of sections allows us to determine directly the force in almost any member. While in method of joints, we were confined to starting with a connection or joint that only has two members unknown. Okay, so here we can directly choose and then solve for a certain force within your truss or system. So let's talk about the steps. So first step, use a cutting plane to pass through the entire truss, separating it into two parts without cutting more than three members. So for method of joints, the rule is you have to make sure you're starting with the connection or solving a connection with no more than two unknowns. Here, it's three unknowns. Why? Because concurrent force systems or method of joints are confined to Fx Fy equals 0. So that's just two equations. So you can only solve for two unknowns. Here, method of sections, we have an added summation of moment equals 0. So now we have three equations. Okay? Again, Fx equals 0, Fy equals 0, and moment equals 0. So three equations, I can solve for three unknowns. So that's why this is our limit. Next step, isolate either the left or right section of the cutting plane. Next, solve using three equilibrium equations. Again, that's Fx, Fy, and moment. And then lastly, repeat method of sections if necessary. So, okay, cut, isolate, solve. That is the basic steps. So for you to better understand, let's dive right into examples. So example number 1, from the thrust shown in the figure, determine the force in members B, C, C, E, and E, F. So everybody, again, prepare your calculator. So recitation will be reset. So those who got points, you can recite again. Okay, since this is considered a new lecture. So here, we're looking for specific forces, B, C, C, and E, F. Okay? So let's note that. B, C, C, E, and E, F. So basically this, B, C, C, E, E, F. So first step is to cut. And where do you want to cut? You want to cut at parts where you want to know where the forces are. So this is what I want to know. So therefore, I'm going to use a cutting plane here. Okay? Next step is to isolate either left and right. Okay? So it's up to you where you isolate. Usually, you'd want to go with the portion with the lesser forces and lesser unknowns. But for this case, it's a bit similar, so it doesn't matter. Okay? Both sides have reactions. So either way, I have to solve for reactions. Here on the left, RA, this is a pin. So reactions would be vertical and horizontal since there's horizontal force. Okay, so RAH, RAB. Here you have a roller, so there's only one force which is perpendicular. So RD. Okay. So if you isolate left, you have to solve for this. If you isolate right, you have to solve for this. So it's up to you what you want to isolate. I want to isolate left side. So let's do that. Okay. So to isolate left, you're gonna draw your pin. That's your point A. You have your reaction. Another reaction. Then draw. Okay. Let me do that. Okay. And then you have this. You're gonna draw up to where you cut, which is this. So we have B, we have this, and then we have this. Okay. So this is your A, B, and then this is point E. Let's zoom in a bit further. Okay. So now what? I'm gonna write the dimensions again. So now you have FB, you have cut members B, C, EC, and EF, or CE and EF. So when you cut, forces will be shown. The same manner where you isolate a point, here isolating a member. So where you cut, forces will be shown. So that means there's gonna be a force AB here, a BC. Okay, yung BC. This is CE, so F, CE. F, CE, and then this is EF. And then similar to what you did with method of joints, you're gonna guess if that is compression or tension. Okay. Now for me, for method of sections, no matter what, I'm gonna assume it's tension. Okay. Because that's just easier to draw for me. Okay. You can do intelligent guess and figure out for this to be in equilibrium. There's a force to the left here, so there should be a force to the right. This is downward, so this should be upward. Okay, you can still do that. But for me, to lessen thinking, I'm just gonna say all of them are tension. Okay, that's just me. You don't have to follow that. And now you have a system, your free body diagram. And what you're gonna do here, okay, this is what I want to know: FCE, FBC, and FEF. You're gonna use your equilibrium equations. Now, this looks familiar, right? It's actually the same problem we answered for method of joints. So we can double check if we get the same answer. So I can just copy the reactions. I don't have to solve. Solving for the reactions is the same process. So I need RAH and RAV. RAV is 10 over 3 kilonewtons downward. So RAV, we can note from previous example. Okay. RAV is 10 over 3 kilonewtons downward. Right? And then RAH is here, 80 kilonewtons. And then RAH, 80 kilonewtons to the left. So this is known, this is known. Okay? I either want to solve for this, or this. So one of the first things you can do is take summation of moment. Okay? Because if you take summation of forces horizontal, I'll have 3 unknowns. Okay? If you do summation of forces vertical, you can solve for this, right? So let's leave that for the last solution. So now I know if I do summation of forces vertical, this is the only unknown that I'll get. So that's one way. Now how about these two? How can I get that? Well, remember the concept of any force that passes through your moment center will not be included in your equation. So that means I'm going to choose a point where most of my unknowns will pass through so that they will cancel out. Okay? So can anybody tell me, looking at the entire figure, at what point does 2 of my 3 forces intersect? Very good. John and Patricia, Relor and Cruz. Relor. New one. Cruz, Relor. Okay, so yes, it's C, but some of you might ask me, why is C? It's not included here. Why am I gonna include that? Well, even though it's not in your drawing, it's still existing in space. So these two, if you extend these two forces, it's gonna intersect at this point. And from the full drawing, we know that point is C. FBC and FEC will connect at C. Okay? So that means I can take summation of moment as at C. Okay? So do that. Summation of moment at C equals 0. So let's start. RAH rotated about C, that is clockwise, so positive. RAH, perpendicular distance, okay? It's this length which is equal to this 0.75. Okay? RAV rotated about C, that's counterclockwise. So negative RAV. Perpendicular distance of RAV from C, it's this length, right? Which is what? Okay, let's look. RAV from C, that's 1 meter, 2 meters. Okay, so even though you draw your free body diagram, you can still look at the original drawing. So that's 2. What else? FBC passes through C, so ignoring that. FCE passes through C, so ignoring that. I'm left with FEF. Rotated about C, that's counterclockwise, so negative FEF. Okay? And then perpendicular distance, again, that is just this length, which is 0.75. Correct? And then there's no other force, so 0. Considering RAH is 80, RAV is 10 over 3, please solve what's FEF. Correct, it's 71.11. Positive, therefore correct assumption. So Jade and Jade and Angela. Simone then. Okay. So 71.11. And then positive, therefore correct assumption. Unit is kilonewton. Again, correct assumption. FEF is tension. Okay, so that's one answer. One force down. You can just box that immediately. Next. What else? Can anybody tell me at what other point does two of my forces intersect aside from C, since we already did that? Okay, not F. Correct, it's E. Bakit? Anong ko? What forces connect at F? It's just FEF, FC, and FB, which I don't care about these two. So no, my concern is with these three. So not F. Instead, it's correct, John. And Kathleen. Okay, so Supra and Pamita. Yes. Supra, Pamita. Uh, okay. Bakit nga ba ito? Well, at A, what intersects is FAB and FAE, which I don't care about. So at E, as you can see at this point, FCE and FEF intersect there. So we can do that. So we can do summation of moment at E equals 0. RAH passes through E, right? So ignoring that. Next, RAV, rotate it about E, that's counterclockwise. So RAV, perpendicular distance is 1. Next, again, FCE passes through E, so ignoring that. FEF passes through E, so ignoring that. I'm left with FBC. So FBC rotated about E, that is clockwise. So positive FBC. And then perpendicular distance is just this, or 0.75. Okay, there's no other force, so equals 0. Knowing that RAV is 10 over 3, please solve for FBC. Correct, it's 4.44 or 40 over 9. So correct, Angela and Jade. Comparing. It's 4.44, not 4.45. If you computed using 10 over 3. Okay, so 4.44, positive, therefore correct assumption. Unit is kilonewton. And again, what is my FVC? Away from your point. So tension. So, and then lastly, what are we looking for? We're left with CE, which I've already mentioned earlier. We can solve using summation of forces vertical. So do that. Summation of forces vertical equals 0. So we have RAV, downward, negative RAV. What else? What's left is FCE, upward, therefore positive FCE. And then get the vertical component. So where is FCE? It's here. So get the slope of that. Remember, this is 1. This is 0.75. In our previous solution, we used that. But again, remember, if you multiply all of this by 4, so 1 times 4, that's 4. 0.75 times 4, that's 3. Right? So now you have the special triangle, 3, 4. And then hypotenuse is 5. Okay? So you can do that as well. So let's use 3, 4, 5. So FCE times, again, we're using vertical, so that's 3 over 5. And there's no other vertical component, so equals 0. Again, knowing AV is 10 over 3, please solve for CE. Correct, 50 over 9 or 5.56. Correct, 5.56. Correct, Jade and Jermaine. But 2 points ka na, Jade, so it goes to Joanna, Corbe, and Tamara. Okay, again, it's 5.56. Positive, therefore correct assumption, it was tension. Okay, so now I have all 3 of what is being asked. Okay, let's compare. Okay, let's see. EF, BC, CE. EF, correct, 71.11, tension. CE, 5.56, let's check. CE, yes, 5.56 tension. And then lastly, BC, is it 4.44? Yes. So as you can see, method of joints, method of section, you should get the same answer. But for method of section, the difference is you can specify which force you want to solve for first. Okay, so that's number 1. Do you have any questions for number 1? Please answer in the chat. All right, great. No questions. Let's move on to the next problem. Okay, the truss in the figure is pinned to the wall at F and supported at a roller at C. Calculate the force, either tension or compression, in members B, C, B, E, and D. B, C, B, E, D, E. So first, I want to mark that out. Just so I have a guide. Again, that's BC, BE, DE. BC, BC, BE, DE. Okay, so I want to know these forces. So again, first step is use a plane, cut through forces you want to figure out. Since these are just three, like earlier, I can just directly cut there. And then you're isolating either left or right side. Now I'd like to ask you, what would be the easier option, left or right? Should I isolate left or right? It's correct. It's left. Angela and Reyes. Okay, pagbibigyan kita kahit LE lang nilagay. Hiring Reyes. Oh, 2 points ganado. Okay, the next one would be Reyes Samantha. Okay. Okay. Yes, kaliwa or left. Why? Because if I'm gonna isolate the right side, I'm gonna have to solve for these reactions. Okay? So to avoid that, I'm just gonna do the right. And once again, we're just gonna draw. Okay? You have that, you have that, you have that. Yeah. And then don't forget the external forces, 80, 60 kilonewton. And then my preference is just deciding all of these are tension. So this is your FDE, this is your FEBE, FBE, and then this is your FBC. Okay, and then just note your A, B, D, and dimensions 4. That's it. So first step, again, you can either start with summation of forces or summation of moment. Let's try summation of forces now, okay? What equation should I use so that I can solve for something? Summation of forces vertical or horizontal based on this? Correct, it's vertical. Germain and Batun for the Batun. Batun. Okay, very good. Again, this is just preference, okay? You can start with moment or just force. So correct, it's vertical. Why? Because if I do horizontal, I'm gonna have 3 unknowns. And again, I can't solve for that. So let's do vertical first, because that's just gonna be 1 unknown. So summation of forces vertical equals 0. This is 80 downward. This is 60 downward. So negative, negative. And then we're left with FBE. So plus FBE and then get the vertical component. So next problem would be, how do I get the vertical component? Well, you're gonna look back at your given. Okay? So FBE, this your BE, for some reason or using some method, I need to figure out what that slope is. So all I know, okay, now if I draw a straight line here, right, I get a right triangle with height 5. Okay, so I know that's 5. And then you have this. This is 4, this is 4, this is 4. Okay, so that means if I draw a straight line here, your 4 will be divided into 2. Okay, so meaning this is 2. So your slope here at the base is 2, and then get the hypotenuse, which is square root of 2 squared plus 5 squared. You're gonna get square root of 29. Okay, again, y height of this is 5, that's given. Okay, this is a symmetrical triangle, 4, 4, 4. So meaning, if I draw a straight line here for your right triangle, this gets half of the total length. So that's 2. Okay. And then just square root of 2 squared plus 5 squared, that's square root of 1. So therefore, vertical component would be 5 over hypotenuse square root of 29. Okay? Are there any other vertical forces? None. So I can directly solve for FBE. Please solve what's FBE. Correct, it's 150.78. Correct, Skylar and Kat. Okay, so again, 150.78. So positive, therefore correct assumption, it was in tension. So kilonewton, tension. And again, that's one of the things we want to look for, FB. So you can just directly box that. Next, someone with DE and DC. So now, obviously, or most likely, I'm going to use moment. So can anybody tell me where should I take my moment so that 2 out of the 3 forces cancel out? Correct, E. One of those is E. So let's give it to Jade. You're already 2 points right. So Kylie and Carla. Joseph. No, so batu. Okay, it's E. So once again, if I extend this, gonna intersect at this point, which we know to be E, right? FDE and FBE intersect at E. Okay? So we can take summation of moment at E equals 0. Let's start with 80. Rotate it about E, that's counterclockwise. So negative 80, perpendicular distance. Look at the original drawing. Negative 80, perpendicular distance from E. This is 4. And we already know this is 2. Let me denote that. That's 2. And this is 2 as well. So perpendicular distance is 6. Right? Extending line of action, this is the length, which is 6. Next, 60. Again, rotate about E. That's counterclockwise. Negative 60, perpendicular distance. This is your 60. This is your E. Extending that line of action, perpendicular distance is this, which is 2. So times 2. What else? FDE passes through E, so ignoring that. FBE passes through E, so ignoring that. I'm left with FBC. Rotate it about E, that's negative counterclockwise, so FBC. Perpendicular distance is this height, which is 5. Equals 0. So now I can solve for FBC. Please solve. What's the answer? Correct. It is negative 120. Remember, sign matters here. So correct, Jermaine, John, Nicole, and Philip. So Borbe, 2 points ka na ata. Yep. So let's give it to Torres, Nicole, and then Pamitan, John. Right, it's negative 120. So therefore, my assumption is incorrect. It's not tension. It's 120 kilonewton in compression. Okay, so again, box your final answer. And then, what am I missing? FBE is checked, FBC is checked, FDE. So where should I take my moment so I can solve for FBE? Correct, B. Correct, John and Ivy, Relor and Johnson. B. Oh, because that B, FBE passes through it, so that cancels out. FBC passes through it, so that cancels out. So I'm going to be left with FDE as my unknown. So summation of moment at B equals 0. Part 80 rotated about B, that's counterclockwise, so negative 80. Perpendicular distance is 4. 60 passes through B, so ignoring that. What else? FDE rotated about B, that's clockwise, so positive FDE. Perpendicular distance is this height, which is 5. So times 5. Again, these two passes through B, so ignoring that. There's no force left, so equals 0. So please solve FDE. What's the answer? Correct, it's 64. Positive. Correct, Skyler. Mark. Mat. 2 points. Hindi pa. Okay, so Skyler and Parabel. Parabel. Okay, so 64. Positive, therefore correct assumption, it's tension. That is the final force. Okay, and that's number 2. Do you have any questions for number 2? Please answer in the chat. Okay, none. Well, that means we can move on to number 3. Number 3 should look familiar to you as well. So number 3, use the method of sections to determine the force in numbers PD, CD, and CE of the Warren truss shown in the figure. Remember, Warren truss means equilateral triangles. Okay, so again, BD, CD, CE. BD, CD, CE. Note that BD, CD, CE, right? Yeah. So those are what I want to figure out. So again, I'm gonna cut there. And then you're gonna isolate either the left or the right side. Okay? So which should we isolate, left or right? Which is the easier choice? Right. So Carla, correct Ivy, but you already have 2 points. And then correct Jasmine. Alanis, Ibarra. So the reason why I'm asking you to figure out which is easier is so that you can solve faster. Okay. So I'm gonna isolate the right side. Let's do that. Drawing. This is E. There's an external force here of 3,000. Let's not forget that. This is 60 EB. That's it. That's what we're working with. And then this is your F. Again, I like making everything tension. So FBD, FCD, FC. Okay. And I have a reaction there. But there's no horizontal force. So there's gonna only be vertical reaction there, RE. And as I've said earlier, we already solved for this. So that's that. So we already solved for RE. RE is 4 or 5. So you can just copy that. From previous example, RE is 4,500 pounds upward. Okay? Correct. Right. So there's a reaction here upward. So don't forget your reactions. Right. So next is to use your equilibrium equations. Again, you can either start with moment or with forces, vertical or horizontal. Now we already know Horizontal will lead to 3 unknowns. So we're going to start with vertical. Summation of forces vertical equals 0. Let's start with this, negative 3,000. Next, this is downward, so negative FCD. Now I need to know the slope. Okay. So to get the slope, I need height. I need this height, which is not given. And then this is an equilateral triangle, right? And I've mentioned earlier, if I draw a straight line there, this is a different color. If I draw a straight line, this is going to be 5, and this is 5. Okay? So now I know the base of this slope is 5. I just need to know the height. Let's call that h. So to get the height, look what are we given. I know this is 60. This is 5. I want to know this. So I can use trigonometric functions, right? Specifically, tangent function. So, saan ba ka? So tangent 60 equals opposite over adjacent, right? Opposite is h, adjacent is 5. So therefore, solving for h, you get 5 square root of 3. Okay? So therefore, yes, 8.66 or 5 square root of 3. So it's better to write the whole thing so that you don't have to store that in your calculator. Yeah. So now, I know height is 5 square root of 3. So note that this is 5 square root of 3. And then square root of 5 squared plus 5 square root of 3 squared, that's just, I believe, 10. Yeah, it's 10. Okay, so now you have your slope. So note that here, FCD, this is vertical. So this is your vertical. So 5 square root of 3 over hypotenuse 10. Right? What else? There's also RE here. So plus, since upward, RE equals 0. Considering RE is 4, 5, I can solve for FCD. Please solve. What's the answer? Correct, Mark and Patricia. So kaya Biag and Taurus. So 1732.05. Positive, therefore correct assumption. Unit is found. Again, it's tension. Okay. So next, okay, as you figured out by now, is moment. Getting moment. Okay, so moment. So where should I take my moment? At what point? So that I can solve for one of the unknowns. Correct, B. So Jade and Marceline and Cruz. Ellie and Cruz. Okay, so at D, it's 1. Why? Because at D, FCD and FBD passes through it, so I'm left with FC. Okay? Summation of moment at B equals 0. 3,000 passes through that as well, so ignoring that, I'm left with RE, rotate it about B, that's counterclockwise. So negative RE, perpendicular distance is this, which is, yeah, if you look at the original, it's this, which is 5. So that's 5. Next, FCE, rotate it about D, that's clockwise, therefore positive FCE. Perpendicular distance is just this height, which we already solved for. That's 5 square root of 3. Okay, any other forces? I believe none. So equals 0. Please solve what's FCE. Correct, it's 2598.08. Correct, Angela Noel. Sorry. Sorry. O, 2 ka na eh. So, salvo. Who else? Simon, Kathleen Castillo. So, 2598.08. Positive, right? Therefore, correct assumption, it was tension. Okay, and then, box that. Now, I'm left with figuring out what BD is. So, where should I take my moment so that I can solve for BD? Correct, at C. Correct, Ellie in Santa Ana. Okay. So that's C. Why? Because that's C. Okay. If I extend this, these two forces are going to connect at C, as you can see here. Okay, so this will cancel out. I'm going to be left with FPD. So summation of moment at C equals 0. Let's start with 3,000. Rotate it about C, that's clockwise. So 3,000. Perpendicular distance, again, this is your 3,000. Distance from C is this, which is 5. RE rotated about C, that's counter. So minus RE. Perpendicular distance is this total length, which is 10. And then lastly, BD rotated about C, counterclockwise again. So negative FBD. Perpendicular distance is this height, which we solved to be 5 square root of 3. Okay? So from this, I can solve for FBD. Please solve. What's the answer? Okay. So I'm gonna give it to Jade and then Sophia. So it's negative 3464.10. So Simon and Dalayo. Simon, you get 3. Dalayo, you get 1. Negative 3464. Negative 3464.10. So meaning incorrect assumption supposed to be 3464.10 pounds. Incorrect assumption tension, so it's compression. Okay, there. That's number 3. Do you have any questions for number 3? Please answer in the chat. Okay, none? Let's move on to the next. Number 4. Okay. From the thrust shown in the figure, determine the force BF by method of section. So we're only looking for one force, BF. Let's do that. Okay. Isa lang. So you can expect this is a pretty short solution if you know what to do. BF, where is that? Here. Okay. So I've encountered a problem. If I cut here, I'm cutting through 1, 2, 3, 4, which is not allowed for unknowns. If I cut it this way, that's also for unknowns. If I cut it this way, that's also for unknowns. Not allowed to cut this way. Okay? So what can I do? Okay? By the way, you can't cut this way even though three unknowns because this is just a concurrent force system. Okay, if you isolate this, you get a concurrent force system, right? And remember, for concurrent force systems, you can only solve up to two. So what? What am I gonna do? Well, if you remember what I did earlier, your by inspection, you can figure out what one of these forces are just by looking at the figure. Okay? And specifically, I can know what this is. FBE. How? Well, if you remember method of joints, right? If I isolate this by method of joints, this is going to be 1.2. So to put that into equilibrium, this is your FBE. And then if I do summation of forces horizontal, I'm going to get FBE equals 1.2. Okay? So by inspection, FBE is 1.2. Okay? So whenever you have something that looks like that, or looks like this, there's a force there, this is equal to whatever that force is. Okay? In the same manner, this is equal to whatever that force is. And obviously, it's the opposite direction. Okay? So it's away from your point, so that's tension. Okay, so now I know this. So I can cut here since it's only three unknowns. Okay? And then you're going to isolate either left or right. Let's isolate the left side. You can isolate the right. So you can, if you want to practice, do that, isolate the right and then solve. But for me, let's just do the left one. Okay? So there. Okay, so this is your B. B. And that cancels out. That is cut. This is cut. We have a roller here. Okay. What else? This is 3. This is A, B, C. There's a vertical force, external force, 2.4 kilonewton. Okay, I think that's about it. And then remember, FBE is 1.2 kilonewton. Okay? Let me notice, specify FBE 1.2. Okay, so now I have three unknowns. And remember, the only thing I want to look for is FB. Okay, so the question here is, where should I take my moment to solve for FBF? Or should I do summation of forces vertical to solve for FBF? What do you guys think? Or should I solve for FBF, knowing everything you know so far? Should I do summation of forces or moment? Correct, moment. But where? Where should I take my moment? If all I want to get is BF. Correct. It's okay. Very good. No, not that way. So correct. Julia. So, and Garing, Kayabyab, Solomon, Santa Ana. Garing, Kayabyab, Solomon, Santa Ana. So very good, guys. That's how you analyze. So I know I have to take summation of moment at A. So that means I actually don't have to get the reaction. Since whatever the reaction there is, it's going to be cancelled. Since I'm solving at A. So that's one thing I can not do. Okay, so let's continue. Moment at A, let's start with 2.4. That's clockwise, therefore positive 2.4, perpendicular distance 3. Next, by the way, this is FBD, FCF, which I don't care about. FBD passes through A, so cancel that out. FCF passes through A as well, right? So that cancels out. FBE, rotate that about A. positive since clockwise, so FBE. Perpendicular distance is this height, which is given to be 4. And then lastly, FBF. Now, since I'm taking it at A, remember your topic for moments. You're gonna place, let me just move this. FBF. You're gonna place that your components of FBF, right? Since I don't know the perpendicular distance of FBF from A, you're gonna use component. So you're gonna place your component at where it's easiest to solve, which is here. Why? Because the horizontal component of FBF will cancel out since it passes through A. And then this is FBB. Okay? So FBE times 4. FBE times 4. So FH cancels out. You're left with FBB. BFB. So FBFB, first of all, I have to get the vertical component and then rotate it. So that's positive, so FBF. Now, how do I get the vertical component? Get your slope. Base is 3, height 4. So this is another 3, 4, 5 right triangle. So vertical, therefore, that's 4 over hypotenuse 5. And then perpendicular distance. Okay, so as you can see, if I extend B, it's going to intersect C at F. So therefore, that is where your components are. And then at F, that is 6 meters away from A. So this is times 6. And then there's no other force, so equals 0. Knowing FB is 1.2, you can solve for FBF. Please solve. What's the answer? Correct. It's negative 2.5. Correct. Skyler Castillo. Pamatmat Castillo. Okay, my point. Castillo. Okay, there. And then who else? Julia. No, supposed to be negative. Ibarra. 5. Okay, so it's negative 2.5. So therefore, incorrect assumption, it's supposed to be 2.5 kilonewton compression. Okay, so that is number 4. Do you have any questions for number 4? Please answer in the chat. How about the others? Hey, great, none. So, this is number 5. Obviously, we don't have time, so I'm just gonna tell you. We want to look for forces AB, BC, and BB. That is basically all of this. Okay? So the technique here is to start with method of joints here to solve for these two. And then you're going to use method of sections to solve for the rest. Okay? I'm going to leave that to you to solve on your own. And then later on, I'm going to upload the solution. Okay? So I'll upload it by Saturday, probably. Then you're going to have a quiz on Tuesday. Topic is method of sections and method of joints. Okay? Quiz on Tuesday. And then remember, during our first meeting, I mentioned you're gonna have journals, right? So for module 2, your journal is midterm assessment. So I'm gonna discuss that. So if you look at your week 5, if you look at your week 5, it's already shown there, midterm assessment. Okay, so answer the following. That's it. You just have to answer. So number 1, what have you learned so far in this class? So when I say that, or when I ask that, I don't mean for you to list down the topics in your syllabus, okay? I want you to list down what you actually understood, okay? Have you learned something in such a way that you can teach it to someone else? And, or what are your favorite topics? What have you mastered? What do you think you're best at? And that's what have you learned so far. Next, what do you want to improve about the class? Am I talking too fast? Are the questions too few? Things like that. Whatever you want to change about this. Am I writing too small? Is my mic too low? The volume is too low. You can't understand me. And all of that. Next, what do you want to keep about the class? Do you like the quiz show? Do you like the pacing, the amount of questions, the difficulty of your quiz? Yeah, just write anything you want to keep. And then, what do you think about your overall performance? Do you think you're satisfied with your score so far with how you're performing for MEC30? Yeah, just write that there. Are you unsatisfied? Why? You think you can do better? And then, lastly, suggestions. Do you have anything that you want to do in this class? What can you suggest to make things better or easier for you guys? There, just write it all there. I read all of those to help me improve the lecture. Okay? So that's it. Answer this. Deadline of this is Sunday, 11:59 p.m. Okay? Midterm assessment Sunday. I'm gonna upload the solution to your number 5 on Saturday, and then quiz for module 2 is on Tuesday. All right? Okay na? Do you have any questions before I dismiss you?
Ma'am, what time po yung deadline ng midterm? Sorry.
11:59 p.m.
Thank you po.
Ma'am, wala pa
Yes?
po siya sa week 5.
Wala pa? Okay. Let me fix that. But wala. A53. Week 6. Sorry, it's at week 6. Ayan. Ando na siya. Okay. Ayan. Week 6. Week 6 ngayon, di ba? Midterm assessment. Okay. Any other questions? Clarifications? Coursera, you can start whenever. I'm gonna upload the submission link here at week 8 for week 3 and 4 of your Coursera. So you can start whenever. Just upload it before module 2 ends. Okay na? Alright. I'm gonna dismiss you now. It's 3 p.m. Since you don't have any more questions, see you on Tuesday. You may go. Goodbye, class.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you po.
Thank you po.